All right, today we are going to look at section 6.5, looking at the law of sines. So in this section, our goal is to be able to relate the sides and angles of a triangle that's not necessarily a right triangle. The problems we've done so far have all been for right triangles. So here I have my triangle. What I've done here is just labeled. So the tradition or the custom is to label the angles in this triangle with big A, B, and C, and the corresponding sides with small a, B, and C. So you see how here I've labeled this guy, this angle, as big A. So its corresponding side, the side opposite that angle, is labeled small a, versus this angle is labeled B. The side opposite that angle is labeled small b. Here's the angle C. Here's the side opposite to that angle C. And then all I've done here is I've drawn in the height. And then I'm going to see what I can do with each of these triangles individually. This is actually a very easy law to come up with. So let me consider first just one of these triangles. So let's see what I can do here. So first I'm going to look at this triangle on the left side here, that guy. I'm going to say, okay, well there I actually have a right triangle. So what if for that triangle I write in the sine? So in that case it would be the sine of the angle B. So for this right triangle, the sine of that angle would be, well, H, that's opposite, over C. That's the hypotenuse. So then it would have to be true then that H is equal to C sine of B. So now let me do the same thing for this triangle. This guy's also a right triangle. So for that triangle, I'd be interested in the sine of the angle C. So looking at the right triangle, the sine of the angle C would just be H over B. So then wouldn't it have to be true then that H is B sine of C? But then what I know is that these two H's are the same, right? The height of this triangle is the same. So that would imply then, or therefore, C sine of B would have to be equal to B sine of C. So this is pretty much my law, but what we do to kind of clean this up is we divide both sides of this by BC. Because here on the left, then I can cancel my C. So I'd have sine of B over B. And here on the right, I would cancel my B, so I'd have sine of C over C. C. So actually I can come up with the third variation of this rule just by rotating, by relabeling the triangle. But let me write that in for now. You probably guessed the third variation. It's just sine of A over A. So this is the law of sines. So this is a very useful rule, and like I said, it's actually one that's very easy to come up with. So let me see what kind of example I can come up with then. So, for example, solve the triangle. So here's the information that's given, say. I'm not drawing this to scale. Okay, so we have, let's see, 45 degrees here, 60 degrees here, and 10 here. So my goal, remember, to solve the triangle, remember I need to fill in all sides and angles. Okay, so I guess I'm missing, let's see, this one would be labeled A, this one would be labeled B. I need to fill those in, and then this missing angle A. Now that one's easy to come up with. That one, let's see, 60 plus 45 is 105. 180 minus 105 is just 75 degrees, so I have that one. That's easy. Okay, now let me see if I can use my law of sines. So I can really set up a whole number of different pairs. Like, look, let's see, I could do sine of 60 degrees. That's this one corresponds with this one, right? Sine of 60 degrees over B. I could do, let's see, sine of 45 degrees. That one would have to be over 10. Or I could do sine of 75 degrees. That one would be over A. Okay? So the thing is, I mean, I can use any of these pairs. Like, I could use this. Let's do this. Let's say I could use this one and this one. I could use, you know, this one and this one. Let's see if both of those would work. So this guy, well, let's see. I'd have only one unknown. It would be this. That would work. Or this one, well, there I'd have only one unknown again, so that pair would also work. I guess my third variation would be, well, I could use this guy with this guy. But if I set those two equal, actually I'd be stuck because there I'd have two unknowns. So I wouldn't want to choose that pair. Either of the others, though, would be fine. As long as I have only one unknown. So I just pick something. So maybe I pick this first pair. So then sine of 60 degrees over B is sine of 45 degrees over 10. So how about I cross multiply? So therefore, 10 sine of 60 degrees is B sine 45 degrees. So actually I know sine of 60 degrees, that's what, root 3 over 2? And I also know sine of 45 degrees is root 2 over 2. How about I multiply both sides by 2? So then, see, therefore, 10 square root 3 is B square root 2. So to solve for B, I would just divide by square root 2. Let me rationalize. That'd be 10 square root 6 over 2. So 5 square root 6. Let me go back and fill this in on the triangle. So this was the side B. 5 square root 6. Okay, what else do I need? So I guess I just need, looking back at the picture, I guess I have 1, 2 sides. I'm missing this side. I have all 3 angles already. So I guess the only thing left is to find that side A. So what pair to use to find the side A? Well, I can use this pair, or I guess I could use this guy with this guy using the B that I found down here, plugging that in up here. It doesn't matter. Oh, I don't know. So I'll take, let's see, sine of 45 degrees over 10 is sine of 75 degrees over A. Go with that one. And then cross multiply, so A sine 45 is 10 sine 75 degrees. Sine of 45 degrees, root 2 over 2. Now 75 degrees is not a special angle, so that one we don't evaluate. So then let me multiply by 2 over root 2 to get rid of this. So A looks like it'd be what, 20 sine 75 degrees over root 2. Rationalize. 20 root 2 sine 75 degrees over 2. So 10 root 2 sine 75 degrees. We go back and put that one up on the triangle for side A. It's this one. A, 10 root 2 sine 75 degrees. So now I filled in that complete triangle. So, well, with that example, the thing is that, you see how I knew two angles? I could immediately fill in the third angle. Well, I guess things are a little more interesting if instead of knowing two angles, I only know one angle. So let me just try to kind of illustrate here. Like, what could happen? So what if I know only one angle and two sides? So I don't want to go into too much geometry, but I'm just thinking like, okay, let me see if I can kind of fix this angle. Call this angle here theta, and here's a side. So I'll try to make these angles, sides kind of look the same for all four of these cases. So I just want to point out there's kind of four things that could really happen. So let's see. So I know one angle, so that's the theta that's shown here. I know two sides. So one of the sides is what I filled in here. But then what could happen depending on what happens with that other side I'm given? Well, I guess one thing that could happen could be this side is too short. So actually, no matter how you turn that side, there would be no triangle formed. So that's one possibility. I guess the second possibility would be this side could be just long enough to hit the base vertically. In that case, I'd have one right triangle. Then what are the other two? So I guess, what if this side is really long? Doing a very good job drawing that one. Do a little bit better, something like that. Okay, then I just have one triangle. Not a right triangle, but it's one triangle. So the third case, or the fourth case, I guess, rather, is, well, what if this side is just longer than this one here, where it was just long enough to form a right triangle? So in other words, what if it's just a little longer than that so I could actually turn it out or turn it in? And so I'd actually have the possibility of forming two triangles. One, doing a terrible job drawing this guy. Try it one more time. So one triangle would be if I turn it just out. The other one would be if I instead turn it just in. So I'd have, this triangle here or this triangle here, okay? But anyway, like I said, I don't want to go too much into the geometry there. I just wanted to point out that there are kind of 1, 2, 3, 4 things that could happen if I know one angle and 2 sides. So let me look at an example like that then. So again, going to be solving the triangle. Let's do this one where it says the angle A is 45 degrees. The side A is 7 square root 2. The side B is 7. So I like to set up a triangle. I'm going to try this fancy ruler. See what this does. So I'm really just starting with a generic triangle. Okay, something like that. Okay, so here's, say, A. Well, let's go with the A, B, C. So here's 45 degrees. 7 root 2 is opposite that, and B is 7. So you see here I can't immediately fill in either of these angles because I actually only know the one angle, 45 degrees. So I'm going to be stuck, oops, finding the side C here first. So let's see what I can come up with. Well, let's start with the pair I know. So the only pair I know here is this pair. So I know that the sine of 45 degrees over 7 square root 2 would be equal to. And then I can choose. Well, I could use this pair or this pair. So I would start with the one where I actually have some information. So I would actually start with this pair because I know the side B at least is 7. Okay, so then let's see, that would be sine of B over 7. So this time I'm actually solving for sine of B. So all I have to do there then is multiply up the 7. So if I multiply that 7 up, I can actually cancel those 7s. So then I would just have sine of 45 degrees over square root 2 is sine of B. Let's see, so sine of 45 degrees is root 2 over 2 over root 2. So how do I handle this? Top fraction stays the same. Bottom fraction flips. Multiply straight across. Okay. So the statement I have here is sine of B equals 1/2. So this is where things get a little bit more interesting because if you think about the unit circle, say, it's a terrible unit circle, but in any case, you see there would be 2 places on the unit circle where the sine of the angle would be 1/2, right? So I guess my first possibility for the angle B would be 30 degrees. My second one would be this one here. So let's see, how do I find that one? Well, look, this is 30 degrees here. This is 30 degrees here. So wouldn't this one then just be 180 minus 30? be 150 degrees, right? So my two possibilities for B are 30 degrees or 150 degrees. So this is why I encounter that possibility of having two triangles, because it's possible that both of those angles may form a triangle. So what I have to do is I have to look back at my triangle. So look, if I look at, say, 30 degrees, well, if I go back up to my triangle here and I say, okay, if the B is 30 degrees, is this possible? Well, yes, because I'd have 30 degrees plus 45 degrees is what, 75 degrees? So what would be left here? It would be 105 degrees here, right? So yes, works. But what about, should I use a different color? What about 150 degrees? So if I take that 150 degrees and I go up here and I say, well, what if I make this angle 150 degrees? Well, then, look, I'd have 150 degrees plus 45 degrees looking for the angle C, right? So that sum already exceeds 180 degrees. So in this case, there would be no such triangle, okay? Because the 150 degrees plus the given angle, 45 degrees, exceeds 180 degrees. It's impossible. So in this case, let me see if I can clean some of this up. In this case, then, I only have one valid triangle. And it's the one in which the angle B is 30 degrees. So in this case, 150 degrees is invalid. So I guess I filled in, have I filled in everything? Well, let's see. I filled in the side, 7√2, 7. I've got all three angles. I guess I'm still missing one thing. I'm missing the side C. Okay, but now I can go ahead and find that. So let's see what information I have that I can set up there. So how about, oops. How about sine of 30 degrees over 7 is equal to sine of 105 degrees over C? So cross multiply. C sine 30 degrees is 7 sine 105. Now 105 degrees is not a special angle. 30 degrees, of course, is. So multiply by 2. So 14 sine 105 degrees. And so we have it. So should I go back up here and put that on the triangle? Okay. So now my triangle is solved. I have all 6 pieces of information. And again, in this case, I had only one triangle to worry about, so I'm done. So here's another triangle. How about the angle A is 60 degrees. The side A is 70. The side B is 144. So, try my ruler. Again. Okay, so let's see, 60 degrees, 70 goes here, A, B, C. So what else do I have? I have 144, and then I'm missing side C. Okay, so again, I have to use the pair that I know. I'm gonna have to use that information. So sine of 60 degrees over 70 is, well, then I have two possibilities. I mean, this pair isn't going to work because I don't know either of the C values. So I guess I would need to use that pair. So sine of big B over 144. So therefore, multiply up the 144. So sine of B is 144 sine 60 degrees over 70. Okay, let me see if I can reduce that. So let's see, I can divide at least by 2, right? What is half of 144? 72 over 35? Okay, that's a start. Sine of 60 degrees, root 3 over 2. Divide by 2. 36 35ths square root 3. So this one's a little more interesting. So this is what I have. So this is like in that previous problem when I was at this line. And I said, okay, well now let me think about the circle. What are the two places where the sine is, a half, right? And then I found those angles, etc. Well, this value, it's not a special value like 1/2, but it is kind of special. Because if you think about that guy, well, let me see. What kind of number is 36 35ths? Well, 35 35ths is 1. So this is a number bigger than 1, right? What kind of number is square root of 3? Well, square root of 1 is 1, so square root of 3 is bigger than 1. So look at what I actually have here. I actually have a number here bigger than 1 times another number bigger than 1. So what is this saying? Isn't this saying that the sine of B is bigger than 1? Is that possible? Think about the unit circle. The biggest that sine can be is 1, right? So I actually have an impossible statement here. So therefore, I would conclude in this case, there is no such triangle. Okay, so make the scratch work. So, I mean, why does this make sense? Well, because I didn't draw this triangle to scale up here. So what if I try drawing this a little bit more to scale? I mean, let's see, I have a 60-degree angle up here. Let me do it this way. We actually just try rotating this triangle. I think it'll be a little simpler. So what if I put my 60-degree angle here? Something like so, right? Okay, so this side is 144. And then this side here is only 70. Well, that's like less than half of 144. So it makes sense actually that that side there is not actually long enough, no matter what this angle is, to come down and form a triangle. So it seems to make sense.